This is Math 2270 coming to you from the College of DuPage, and this lecture is Calculus Review Solutions, Low Stakes Assessment 1. It's useful to do this exercise because calculus skills are required and need to be refreshed often. It gives an indication of the expected rigor of the course, and it is a strong predictor of success. I have to give you grades, and having an earlier one rather than a later one is good. And this exercise also gives a bit of a preview of the higher stakes assessment processes and protocols. The rubric is I picked 10 of the problems, and you put them in the answer sheet, and I'll grade them right or wrong, 5 points each, and those are pretty much where those 50 points come from. I will also evaluate the PDF upload, and there's 50 points associated with that. My only regret is that I did not pick one of the 10 to be partial fractions, but there were plenty of opportunities to practice those among those problems not selected. The first problem was number 52. So if the series up here converges, to what does it converge? And I gave you a bit of a hint here. The series in 51 is a very famous math history problem called the basal problem. It is a p-series and converges absolutely, meaning you can pretty much do anything you want to it and it still converges. And we know the p-series converges to pi squared over 6 because I told you that. Now, the key to doing this problem is to note that if you sum from 1 to infinity 1 over 2n whole squared, that's going to be, the 4 will be there and can be factored out, so it's 1/4 times the basal series itself, so it's 1/4 times pi squared over 6, and that ends up being pi squared over 24. Now, so that means that the even ones sum to pi squared over 24. The entire series sums to pi squared over 6. So the series I offered you is going to be pi squared over 6 minus pi squared over 24, which is pi squared over 8. Problem number 2 was problem 40, and this was dealing with velocities, accelerations, and such, and these are important kinds of things even in differential equations. So I asked a whole bunch of questions about that, and I gave you something that gave the position function at time from 0 to 8. So I asked about the velocity and acceleration at 2 seconds, and you take the derivative and get this for the velocity, and the second derivative is this for the acceleration. You substitute 2 seconds in, and you get the velocity is 0 at 2, and the acceleration is minus 12. The next question asks, when is the particle going left? And the particle is going left whenever the velocity is negative. You solve this by factoring and doing test points, and the solution is between 2 and 6 seconds. It is going left. I also ask, when is it slowing down? Slowing down means that the velocity and the acceleration have opposite signs. So that means the velocity times the acceleration is less than 0. That means they have opposite sides. One of these has to be negative, and that means the solution is going to be either less than 2 from 0 to 2 or from 4 to 6. I ask about the minimum and maximum values from 0 to 8. Well, it was a continuous function and we knew when it was 0, so critical points are 2 and 6, and you have to check the endpoints as well. So I look at this, and the minimum value is minus 20, the maximum value is 12. I also asked, how far did you travel? Well, you went from minus 20 to 12, and then you went back down again, and then you went back up again. So one way to consider this is that you did 3 times 32, or 96. The other thing you could have done was integrate from 0 to 8 the absolute value of the velocity to get 96. Problem number 3 was calculating this integral, and the concept here was to realize that the tangent of pi over 4 is 1, and so you're integrating 1, so you get x plus c. Problem number 4 asks you to find the equation of the tangent line to this curve at this point. Well, this is a wild and crazy plane curve that you see over here in the red, and being that wild and crazy, you can't really solve for y. So what you have to do is do implicit differentiation. So I do implicit differentiation here, then I substitute 1/2 in for x, and I find out that the slope is minus 1 over pi over 2 minus 1. And so then it's going to be y minus the y coordinate is equal to the slope times x minus the x coordinate. And you can see in this curve where that is happening. Problem number 5 asks you to compute f prime at pi over 3 and f double prime at pi over 6, and this was f. So you take the derivative. Now this did require you to use the second fundamental theorem of calculus. So that tells us that what will happen is we will substitute the sine of x in for the t, and that will be the first part of the answer. But then we have to use the chain rule. That's going to be the cosine of x. And then I ask you to plug it in. By the way, this is going to be cosine squared by a trig identity. So this is cosine cubed. That's going to be easier to take a second derivative of that than this one, a little bit easier. So when we substitute pi over 3 in there, the cosine of pi over 3 is 1/2, so if you cube it, you get 1/8. Now the second derivative, I'm going to use this expression for the first derivative, that is the cosine cubed. So it's 3 cosine squared x times the negative of sine x, and I'm plugging in pi over 6, and I get minus 9 over 8 as my second answer. Problem number 6, you were to evaluate this integral. You have to use integration by parts here. U is going to be secant t, and dv is going to be secant squared t, and you do this. Now this is an integral that you end up integrating, and you start out integrating it, and then you'll get the integral over here again. You have to bring it over here. That's what gives you this 1/2. And so this is what you get when you do the indefinite integral, and when you evaluate it at these points. I do expect you to be able to evaluate these things without a calculator. You will get this as your answer. And sometimes you will come up with an answer that looks different, but I always will check the decimal to see if in fact your answer is a correct answer. Number 7 is integrating this. You're to use a trig identity. 1 minus cosine x over 2 is known to be sine squared of x over 2. X over 2 being the argument there. So we will make that substitution, and then the square root of that squared is going to be the absolute value, and we're integrating from 0 to 2 pi. So this is what happens. It is one hunk of the sine curve. The period is changed, and so it is this area, and the extra 2 comes because of the change of variable, because you're integrating the absolute value of sine parentheses x over 2 into parentheses. So you get 4. 8, you have to integrate by parts 3 times. And this is what you get, 6 minus 16 over e. Usually I'll be asking for the exact answer. This is where you would leave it. But again, if your answer looks different, I'll check it to see. Problem number 9, you have to do integration by parts again. And in this one, you let u be ln t, and you let dv equal dt. We do that, so that is uv minus the integral of v du, and evaluate it at the endpoints, and you get 1 for this integral. And here you're supposed to declare or evaluate to see if this is a divergent or convergent integral. We do indefinite integrals, or improper integrals, I guess I should say, when we're doing Laplace transforms. And so we use the limit definition of this, and it is 1 over 2e is the exact answer. In closing, now more than ever, time is precious. Each day must count. Do the math, it'll make you strong. And now, more than ever, take care of yourself and of each other. And now I have grading to do. God bless you all.